Alabama STEM Explorers is made possible by the generous support of HudsonAlpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Holly Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, Alabama Math, Science, and Technology Initiative.
Thanks for joining us today on Alabama STEM Explorers. I'm Cruz.
And I'm Keshia, and we're here at Southern Research in Birmingham, Alabama.
Hey guys, I'm really excited. Last month, our teacher gave us all a pack of flower seeds so we could grow our own flowers at home. I've been keeping my flower in a safe place so we could grow big and tall. Let's take a look.
Yeah.
Oh, are you kidding me? There's supposed to be a flower in here. There's no flower.
There is no flower. Cruz, how often did you water your plant?
What do you mean?
Like, did you water it once a week, once a day?
I was supposed to water it more than once?
Yes. Did you give the plant any sunlight?
I mean, no, it was in my closet.
Cruz, that's why your plant didn't grow. We have to make sure our plants get everything that they need for growth. I think we need to look at this experiment here, and I think that will help us get a better understanding of why you didn't get any plant growth.
Okay.
Let's first start off by talking about seeds. You said your teacher gave you some flower seeds, but these are some seeds that are edible. So what kind of seeds are these?
Popcorn seeds.
Popcorn seeds, and if we add a little heat to them, what do they pop up to?
Popcorn.
That's right. Who doesn't love popcorn with their
Movies.
All right, yes. And here we have lima beans. These are lima bean seeds, and they're edible. So some seeds are edible, but the seeds that you planted aren't edible. They were supposed to grow into a flower. So let's check out why. So we're gonna first start off with our system. This is a growing system. I have mine already set up, and I want you to set yours up. So here, this is called your planter cup. This is your wick, which is gonna be used to help transport the nutrients. And this is your reservoir. Inside the reservoir, you'll see a little blue square. It's a copper sulfate square. Do you know what it might be used for? What it might prevent?
I don't know what it is for.
It's used to prevent algae growth, because we don't want algae growing in our plant system. So we're gonna first start off with filling up your planter cup with some of that soil there. And that soil is going to contain the different nutrients that your plant is going to need for growth. And I have some more flowering seeds for you so that you can plant them. So go ahead and put your planter cup inside the big reservoir and pull your wick down just like mine is. Make sure it reaches the bottom, but leave room at the top. Great.
Yep.
All right, now go ahead and I want you to put the soil into your planter cup. Fill it up to about this line here.
Okay.
Doing an awesome job.
Thank you.
Now just go ahead and open up your seed packet for you. And as you fill that up, we want to make sure we level it off before we plant our seeds inside of there. Looks good.
Yep.
All right, so pick you about 8 seeds and just kind of plant them around. Don't put them all in one spot. Okay. You want to plant them around inside of your planter cup. Wow, I think I counted out exactly 8. So go ahead and put those in there. Yeah, all right. And spread them out. Then I want you to take just a little bit more soil and just cover it up. We want to make sure they are covered. You don't need a whole lot, just a little small amount and to cover it up. Great, and then just spread your hand on top to just kind of make sure it's leveled off, and that's good to go.
Okay.
All right, so here, we also want to make sure that we give the plants everything that they need to make sure they're growing. And so we have different types of nutrients that are for our plants. There are 13 nutrients that plants need. 3 of the macronutrients that plants need are super important. And those 3 are going to be phosphorus, potassium, and nitrogen. And so this all-purpose Water-soluble plant food has nutrients in it. It also has the micronutrients that the plants needs for growth. And so those macronutrients we've named, and we also have micronutrients. So do you remember us talking about any of the micronutrients?
Magnesium?
That's right. Magnesium is one. Calcium is another, and sulfur. And so these are already mixed in this solution that we have made here. So I'm going to pass this to you because we want to make sure that our plants get the nutrients that they need so they can have what? Growth. Yeah, we don't want it looking like that pot over there. So I want you to measure out 250 milliliters of this liquid nutrient solution.
Okay.
And I'll hold this for you. And remember, pour it slowly. We don't want it to spill. And we want to get to 250. And so we're almost there. Just a little bit more. Okay, we're almost, so start slowing down because we don't want to go over that mark. Okay, go up, go. A little bit more. And you're there.
There we go.
Good job. All right, so go ahead and pour that on top of your seeds. So that's going to mix in what the seeds need. And just pour it slowly as it pours on top of there. And we have the wick there. What do you think the wick is going to do?
The water is going to drop down into here.
Yes. Sometimes, we don't want to give too much nutrients and we don't want to have too less. So it's going to help in balancing it out as well and making sure. It may just take a little minute as it starts to, and you'll start to see some of anything that's excess is going to run over. All right, so while you're doing that, I'm just going to talk about our macronutrients. So, for instance, we know that when our plants grow, they get these leaves. Our leaves, what color do we want our leaves to be?
Green.
Green, that's right. But sometimes they become a little yellowish or they might become a little brownish. And what do you think that might be because of what?
I don't know.
They're probably missing something, right? So our macronutrient that's going to help prevent the browning of the leaves or keeping our leaves from turning yellow is going to be, do you remember what I talked about earlier? So we talked about 3 macronutrients.
Oh, yes.
And so we had which ones? Nitrogen, phosphorus, and potassium. So nitrogen is going to be that one that's going to help prevent the yellowing of the leaves. If you see plants, their leaves are yellow or they're turning brown, that means that the levels for that macronutrient are not where they need to be. Then we want to make sure we have a strong root system. So to ensure that we have a strong root system, we want to make sure that we have phosphorus there. And then potassium is going to help with the plant when extreme temperature changes because we want our plants to be able to survive and those strong temperature changes. And so we see here that anything that was excess is moving down, but we have a root system. And so as those plants begin to develop and our seeds are growing, they're going to start developing roots. And they can pull those nutrients through the root system that's going to help them in their growth. So I think once we finish with this and we allow them to grow and we give it sunlight, I think you'll have a nice plant. And it won't look like that pot over there. Because what do we want? Growth.
Growth.
So a happy plant is a healthy plant. As this plant begins to grow, we're then going to transport it to the other pot that's over there. And then our end result that we expect once you take care of your plant is to get a beautiful plant like this that's healthy and beautiful and has blooms. So we made sure that you will have the right type of nutrients and the sunlight, and this will get you this type of product. So it won't look like that one, but it'll look like this. So as we move forward, Cruz, the next time, we're going to have a plant that looks like what? That's correct, because we're going to make sure it gets all of the water, the nutrients, and the sunlight that it needs. And we look for happy what? Growing.
Plants give us so much, not only environmentally, We enjoy what they do for the environment. We enjoy what they do for us personally. Whenever I walk out in a garden, whenever I get to get my hands dirty, it is a stress reliever for me. I'm a regional extension agent, and I have 2 primary responsibilities, commercial and home grounds horticulture. And they're really kind of separate positions. So in my commercial role, I support the green industry in and around Birmingham, the Birmingham metro area. So I work with landscape contractors, with commercial growers, that kind of thing. On the home ground side, I work with the general public. I also coordinate the Master Gardener program. We answer gardening questions. We have booths out at farmers markets and just do public outreach. So it's really no day is ever the same. Related to STEM, the landscape industry, the horticulture industry would hit all of the tenets of that program. So when you look at science, I mean, you're dealing with plants. Those are living organisms, and we learn how they react biologically. We start literally from, not from the ground up, but from under the ground. So we look at the soil and we see how the soil chemistry works with the plant and how pH affects things. Is your pH too low or too high? That's going to affect plant growth. So we're looking at chemistry, looking at the technology. There's so much technology that's used now, whether we're looking at apps that are IDing plant material from your phone, you're taking a picture trying to figure out what that is. We're using computer-aided design programs in the landscape design, landscape architecture fields. Then we look at engineering. A lot of the designs that go in are very intricate, and so that needs to be taken into consideration. And then math. I mean, we can start from the basic level, moving up to more advanced levels. In a lot of outdoor classrooms, they may have raised beds. They're using those beds. Let's calculate soil volume. Let's look at our weather station and do comparisons on maximum and minimum temperatures and that kind of thing. So really in horticulture, we hit all of those and more.
Hi, I'm Neil, and Nilah and I are here at the HudsonAlpha Institute for Biotechnology. Nilah, I have a question for you.
Okay.
How many plants do you have at your house?
I'd say I have about 4 plants at my house.
You're sure about that? If we
Yeah.
walked to your house and walked in and outside your house, we would find only 4 living, growing plants.
I'm not sure. I don't really know how many plants then.
You know, I think most of us don't really pay attention to the plants that are inside or outside, but plants are so important. Plants provide most of our food, our fruits and vegetables. Mm-hmm. Plants provide all the oxygen that we breathe. You and I like to breathe.
Yes.
Breathing is a good thing.
Yes.
Plants purify the air. Plants are so critical, and most of the time, we just walk right past them.
That's true.
So for this activity, we're going to intentionally slow down and take a closer look at plants and some of the differences in the plants. So I've got a whole set of leaves and seeds and shoots and roots and flowers. The plants that we generally think of as flowering plants, where we get our food and our flowers, are called angiosperms. And there are 2 broad categories: monocots, which means 1, mono, and dicots, and di means 2. And we'll dig into that in just a second. But let's start right here with seeds.
Okay.
All right, take a look at these seeds. Tell me what you see or what stands out to you about them.
They all have different sizes and shapes.
Yeah.
I notice corn right there. I also notice some sunflower seeds and some apple seeds.
Yes, that's right. Teeny tiny, that's radish.
Oh, okay.
That's a plum pit.
Wow.
And that's cherry. So we've got a whole bunch of different kinds of seeds. And what's really neat about a seed is the seed contains everything that a plant needs to form a new plant. So there is an embryo, a tiny plant inside each one of these seeds. That's really cool. The potential of a whole new plant inside one of these. And you can actually see these. You can see the new plant emerge if you germinate them. That means to have it sprout at home. And this is really simple. Nilah, you and I could do this in about a minute and a half. We take a Ziploc bag and a piece of paper towel, and we put some staples in the bottom, and we set the seeds in, and we add some water, and you tape it up in a window. And in about 5 days, you've got something that looks a whole lot more like this.
Really?
Yeah. That's pretty cool, isn't it?
Yeah.
That looks different from these kinds of seeds.
Yeah.
But this is the beginnings of the new plant. So tell me, what do you see that's different between those?
This one has purple roots, but this one doesn't.
Yes.
And I also see that this one is a dicot. This one is a monocot.
And how do you know that?
This one has two green pieces.
That's right. The cotyledons, where the cot comes from, that contains the nutrients for the growing embryo. And if we look at this really closely, if we separate this apart, you can see that plant in the center.
Yeah.
That's the beginning of this bean plant. The monocot doesn't have that split apart. It's just one entire kernel of corn. All right, so let's jump now. We talked a little bit about roots. Let's look at the roots of a full-grown plant.
Okay.
So let's talk about the difference between these. And I'll tell you up front, this is the dicot and this is the monocot.
Okay.
And the ground is about, this is where they both would be in the ground. So what do you see about differences between those?
This root is longer than this one, and the roots are curlier than the roots on this one. And I noticed this brown chunk.
Okay, so dicots have a really long taproot. So, and then they have a few roots that come off it. They go deep into the ground.
Okay.
Monocots don't have a long taproot, but they have lots of little roots around it. So they generally sit closer to the ground.
Oh, okay.
All right, so now, seedlings, roots, let's talk leaves.
Okay.
We have a whole lot of different leaves here. What do you see? What stands out to you? What are some things that you see that are different among these leaves?
Some of them are just one long, strand of grass.
Like this one.
Yes.
Yep.
And some are purple leaves. I also noticed that this one is green and it goes into white. And this one, or some of them have multiple leaves and they have longer stems.
All right. So you've got a lot of differences in these leaves.
Yes.
The key difference between our monocots and our dicots has to do with the veins that are in them.
Okay.
And the veins carry the water from the roots all the way up. So if you look at, let's start with one of these, or with this one. The veins all run in parallel. They all run from the bottom all the way up to the top. You can actually see that here because you can see how all of the veins start at the bottom and they run all the way to the top. That's different from a plant like this, where they actually branch out.
Yeah.
And then there are lots of little branches beyond it. So the dicots have the branching.
Okay.
There's the branching. We've got lots of branching. This one kind of looks like the fingers on a hand.
Yeah.
And then the monocots all run in parallel. All right, now quiz time.
Okay.
Pull that set of flowers over here. This vase contains monocots and dicots.
Okay.
What can you tell me based on looking at the leaves? Pull out the ones that you think are the monocots based on what we talked about with our leaves.
Okay. This flower has a dicot leaf.
All right,
And
I'll hold the dicot.
this flower has the monocot leaves.
So we talked about how the dicot leaves branch off and the monocot leaves all run, the veins all run in parallel.
Yeah.
All right, so now let's compare flowers.
Okay.
Specifically, let's look at the number of petals. All right, dicots have lots of petals around them, usually 4, 5, a dozen or more, just like these chrysanthemums.
Okay.
You've got a plant called an Alstroemeria, which is a really tongue twister, an Alstroemeria. And the monocot flowers all come in multiples of 3.
Okay.
So let's take a look at this. So we've got 3 outer layers, 3 outer petals, and then we've got 3 that have these stripes on them. This is kind of like a tiger.
Yeah.
3 inner stripes. So it comes in multiples of 3. Let's look at this lily. All right, monocot or dicot?
Monocot.
And how do you know?
Because the veins are running parallel.
That's right. And then look at the petals. What can you tell me?
They are in sets of 3.
That's right. We've got 6 petals
Yes.
on our lily. Well done. You passed the quiz. So if we were to walk back through your yard,
Okay.
I bet that we would be able to look at your grass. We could determine. So what do you think? Does this look like a blade of grass, sort of?
Yes.
Your grass is a monocot. We could look at your shrubs. We could look at your trees, and we could identify monocot, dicot, monocot,
Yes.
dicot. The incredible world of plants. We don't pay attention to them,
Yeah, we don't.
but when we stop to take a closer look, we discover so many things about them, and we can classify those based on all these different things that we know.
Yeah. This is really cool.
Yeah, I never paid attention to plants
Me
until I
either.
started thinking about these. And now I look at these all the time. Very cool.
Hi, my name is Noah, and why do leaves change colors in the fall?
I think fall is my favorite season. This is a great question. During spring and summer, when there's plenty of sunlight, plants make a lot of chlorophyll. In the fall, because of changes in the length of daylight and changes in temperature, leaves stop the food-making process. The chlorophyll inside the leaves break down, the green color disappears, and the yellow to orange colors become visible and gives the leaves part of their fall splendor. I love fall.
I am the founder and lead naturalist at Butterfly Outdoors. We are a nature-based education company and guide service. So we work with people of all ages, literally from 0 to senior citizen. I've led people on hikes that were in their 80s and 90s, and the Wander Tots group that I've been working with today has children as young as 4 months in it. Our goal at Butterfly Outdoors is to help break down any barriers that people face to getting outdoors and exploring nature. Sometimes those might just be lack of skill and knowing where to go. Sometimes they may be lack of funds. So we work with all different groups to try and break down those barriers. I know that typically young children need an adult to mentor them into the outdoors. For it to be most successful for a child to make a connection with nature, they need a nature mentor to lead them there. As a child, my grandparents and parents served in that mentor role and helped me connect with nature. And I know that not everyone has that today, so I like to serve that role as best I can. And not just mentor the children into nature, but help guide their parents into leading those discoveries for their children as well. I grew up outdoors, hiking and camping with my family. I was in Girl Scouts. I went all the way through and got my Gold Award, which is the Eagle Scout equivalent. So I've always known that nature was a special place for me that I really loved. When I was in college, I did an Outward Bound Wilderness course where I learned that it was something that I could do as a career. And I met with a park ranger in Yosemite Valley that led me into forestry. So I got my bachelor's and master's degrees from Mississippi State. And even while in school, I worked in nature-based education and knew that this was something that I wanted to do with my life.
Thanks for watching Alabama STEM Explorers. If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week.
Alabama STEM Explorers is made possible by the generous support of HudsonAlpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.